Okay, so the first one is one that we've kind of done before, okay, and that is when you're doing combination of functions, and you'll see it in a separate slide with multiplying and dividing. But if you are looking to combine functions, remember that f plus g of -3 is really just saying f of -3 plus g of -3, right? So you're plugging those in. And so if you're using your ti89s for this, especially because there's two questions, it's probably worthwhile to go ahead and insert the functions into the y-editor. So I'm going to hit diamond F1 to access the y-editor, and here I'm going to replace what I have with these two functions. So 3x squared minus x minus 5. So there's my y1. And then y2 is my g function, which is x squared plus 5x plus 5. And so when I enter those in my calculator, what I can now do is come back here and I can access these. Remember, the f is y1 and the g is y2. And so the easiest thing for me to do to calculate this is just from my home screen. I'm just going to type that out. So y1 of -3 plus y2 of -3. And I'm going to go ahead and hit enter, and I get my solution here, 24. Okay, so if you do the same thing with f minus g of x, again, the only difference I need to make is to change this from a plus to a minus. And so I can evaluate that second question here simply by changing that sign, and I see it gives me the difference here of 26. All right, so that's, again, just using the y-editor, okay, and the function notation capabilities of the ti89. All right, continuing with this, just really quickly, all I wanted to do here for this is just talk about how you can express your calculator in scientific notation form. The scientific notation. Okay, and so just really quickly again, this EE button right here represents, down here to the left of the 4, represents the times 10 to the power of. So 5.01 times 10 to the 7th can be expressed as 5.01. This EE button only types a single, the E here to represent scientific notation. That stands for times 10 to the power of, so you just put the power there. And then times the next term, which is 9 times 10 to the power of -2. You can include the negative sign. Make sure you use the change of sign key, not the subtraction key. And that will give you your answer. So this would be the answer. Now notice this answer didn't give us the answer in scientific notation. If you want the answer in scientific notation and you don't want to do it yourself, again, you can still do it yourself here. But you can change the settings on your ti89 by going into this mode. So to access mode, it's a white key. So we hit alpha mode, we go into that mode button by just clicking mode. And the exponential format is located here, or the scientific notation format is located under this exponential format. So if we scroll down to this 5th line here, change it from normal to scientific, hit enter. Now it will give all of your answers in scientific notation. So now if I hit enter on this, I see that it converts it into that scientific notation for me. I would have gotten the same thing here, times 10 to the power of 6. And so if you need all of your answers in scientific notation, you can go ahead and go in and change the mode itself. Okay? Now, it's rare to want to keep it in that scientific notation, so I'm going to go back and change that back. So again, go into the mode button, go down here to exponential format, and now I want to change it back to normal. Okay, and so here it will only give you scientific notation if it needs to in order to display the digits. Bless you. All right, so that's the second part here. The next is, again, just some of the concepts as far as expanding polynomials. If you come back and use the y-editor once again, so here we'll access diamond F1 to get to the y-editor. We'll clear what we have. And if we plug in this function, 5x squared plus 3x minus 7, okay, so enter that into your Y1 editor. What we can do is come back into the home screen, and if we type in our function y1 of, and we enter the expression here, this binomial x plus 4, and hit enter, notice it expands it and puts it into that polynomial form for us. So we would get our answer here as 5x squared plus 43x plus 85. But again, notice it just evaluated and expanded our function notation for us as long as we put our outer function in the y editor. Right, this is going to continue to be what you see, again, chapter 5 dealing with these polynomials here. Here is the other two combination of functions, which are multiplying and dividing. Okay, with the multiplying ones, it should automatically expand them for you. So if we come in, again, the f of g of x is really just saying f of x times g of x. So what we want to do is enter our two functions in the y editor. So diamond f1, we'll go clear this and enter 3x minus 7. And as y2, the g function, we'll enter the quadratic x squared minus 3x minus 4. Okay, once we get those entered into our y editor, we can go back to our home screen and just type what we have. We're taking y1 of y2 of x, close that off, and hit enter, and it evaluates that for you, and you wind up with your expression here. To be 3x squared minus 9x minus 19. Oops, let me go back. I actually did composition of function there, so hang on just a second. So this one wasn't y1 of y2, that's the composition of functions. This one is multiplying them. So when we access it, we'll access y1 of x times y2 of x. And this is going to be our multiplication, the product of these. So here, oops, in this case, it looks like we have to put it into the polynomial form. So if you remember, the command for that is expand. So I'm going to hit this this left arrow key to get into the front of this entry. And up here under F2, I'm going to select expand. I then scroll over or hit second right. That'll jump all the way to the very end and close off the expand commands. And so here would be our solution. 3x cubed minus 16x squared plus 9x plus 28. And so that would be the whole value multiplied. Now, in this particular case, if we're dividing, this is f over g of x, remember, is f of x divided by g of x. If we needed to write this out in a form where we have the remainder and use like long division, we could express it as y1 of x divided by y2 of x. Now, more than likely, this is just going to copy those each individual expression. And so this one, it doesn't benefit you. Oops. There's a whole different problem here. So for this one, it has a new set of f and g. And so if we look at this case, this one's unnecessary to use a calculator, right? F of g is 7x plus 8. Or the f of x is 7x plus 8. G of x is 3x minus 10. So that would be the simplified form here. The calculator is not going to be anything different than that. But you could enter it and evaluate it in that form. All right, what happens though when you are looking to evaluate? And I think we talked about this when we did in class, but I'm not 100% certain, so let's talk through it. if you are looking to divide a polynomial and use either long division or synthetic division if that applies, you don't necessarily have to enter these in your y1 and y2. You can just enter the expression exactly as it appears. Now notice what happens when I do this though. If you need to, it may not expand your answer for you. So let's take a look at what happens here first, and then I'll talk through the possibilities. Right, so I write my whole numerator in one set of grouping symbols, divide by, put my whole denominator in a second set. Now, this is a case where we're expecting our answer to be in the form of a simplified fraction followed by a remainder. Notice that this is just one single fraction. So all it did is kind of copy down what we had. Okay? So in order for us to get this into the form that we need, you need to use the expand command. So once again, I highlighted my line, hit to the left cursor to get all the way in front. I'm going to insert the expand command, so F2, option 3, insert commands, and then if I hit, or expand, and then if I hit the second right arrow, jumps all the way to the very end, I can close off the expand, and now this gives me that form. Now it puts the remainder first. So when you write this answer, notice that the 2x squared minus 5x minus 5, that's the original sort of a quotient that you're left with, and then plus a negative, or plus a negative, so just minus 5 over 5x squared plus 3. Okay, so this is sort of how, how you would express this. If it asks you what's the quotient with a remainder of, the remainder would be the negative 5. The quotient would be the 2x squared minus 5x minus 5. Okay. If you have a denominator that's different than what the original denominator is, so notice in this case that's not true. In this case, our denominator here is the same as what we have. If it gives you something different than that, and you need to find the remainder, the way that you would do that is that you could just highlight the answer before, or highlight the answer in that simplified form. You're then going to delete everything that was not part of the fraction. So here I'm just going to delete all the way up to this, the x squared, 5x squared plus 3. So right to this point. If I delete all of this, and I take that expression, so I'm just going to hit enter to input it as a line on my ti89. And then if you multiply by whatever the original denominator was. So if I multiply this, I'm going to put parentheses, a 5x squared plus 3, close that off. When I hit enter here, the number that I'm left with should not be a fraction, okay, and that number will be your remainder. So here the remainder is negative 5. Like I said, in this case, it was already established because the denominator was the same. But there are instances where some of the factors might reduce down, and you're left with something different than what the original denominator was. So if that is the case, that's how you would adjust it. All right, so that is all of the Chapter 5 material. Chapter 6, again, I'm just going to go really quickly because Chapter 6 is super straightforward. It's very helpful. It's the reason why you can't use ti89s for this class and most of the algebra-based classes, and that is because it does all the factoring and solving for you. So I'm going to go through just one example on it, and then the rest of them are done the same with the same process. So if you're looking to factor any expression on the ti89, you can access it through this F2 Algebra tab. It's the second option. And then you just type in your expression exactly as it appears. So I'm going to use this second one right here. So we get 5x to the third plus 4x squared plus 5x plus 4. You don't have to put parentheses or anything, just close out the parentheses on factor, hit enter, and it gives you your factors. So it's the two factors here would be 5x plus 4 and x squared plus 1. All Right, so that's any factoring, doesn't matter how complex it is. So even looking at these with the different patterns and the different variables, it still holds true. So here, if we're looking at any of these patterns, let's go ahead and do this sum and difference of perfect cubes here. So we'll look at this third example. Factor it, hit F2 algebra tab, choose factor, type the expression. 3, you can even use different variables. Here, 3p squared plus 243. Close that off and hit enter, and it's going to give you your factors. It's the sum of squares, so you just factor out the p, and that leaves this remaining expression. All right, so the factor command is built in, and it's very useful if you have an opportunity to use the ti89. The last one that's also very useful is the solve feature, the solve command. And if that's the case, as in this problem, just hit, again, it's under this F2 algebra tab. It's the very first option, solve. Type the equation exactly as it appears. And then tell the calculator what you want it to solve for. So comma x tells it we're solving for the variable x. And when we do, we get our answer. And so in this case, it's 7/2 and 5/3. Right, and so the rest is just making sure that you can solve it. So again, if you are looking at this last example here, story problem, where it's asking when does the ball hit the ground, the height when the ball hits the ground has to be 0. And so if you just plug in a 0 for that and solve, you would get your solution. So if we use the F2 algebra tab, hit solve, type in our equation, 0 is equal to negative 16. T is up here along the common variables because of the time. It represents time in equations, plus 32t plus 240. We want to solve for t, so comma t, close it off, and this will give you the time values for which that's the case. So the answer is 5 and negative 3. Notice that you can't go backwards in time. So negative 3 is an extraneous solution. The calculator won't tell you that. You just need to be able to interpret that from the problem itself.